So this is lesson 1.2 on prime factorization. So secret codes are often used to send information over the internet. Many of these codes are based on very large numbers. For some codes, a computer must determine the prime factorization of these numbers to decode the information. The prime factorization of a number is the number written as a product of all of its prime factors. Do we remember the difference between prime and composite numbers? What's the difference? Who can tell me what the difference is? Emmanuel.
Prime is odd and composite is even?
Not necessarily, but that's a good way to think about it. So a prime number is a number whose factors are 1 and itself. So 3 is a prime factor because its factors are only 1 and 3. 5 is a prime factor. 7 is a prime factor. 9 is a prime factor. Okay? A composite number has more than 2 factors. For example, 10 has 1, 2, 5, and 10. So that makes it composite. So when we're doing prime factorization, we have to make sure that we get all the way down to all prime numbers. Okay? So one way to do this is to use a factor tree. Raise your hand if you did this in 5th grade. Maybe? No? Okay. So the key for a code is based on the prime factorization of 180. Find the prime factorization of 180. So first, we're going to choose any 2 factors whose product is 180 and continue finding factors until only prime factors are left. So we want to use basic facts here. So we want to think that 10 times what number is equal to 180? What is it? Riley?
90?
Nope. Corbin? 18. Good, so 10 times 18 equals 180. So here's 180 at the top of our factor tree. Now we have 10 times 18, okay? Are 10 and 18 prime factors? No, so we want to keep going. So for 10, we have 2 times what, Ashley? 2 times 5, good. And for 18, we have 2 times what, Nora? Or sorry, 6 times what?
6 times 3.
6 times 3, very good. Are there any prime factors on this row? 2, 5, 6, and 3? 3. What else? 5. What else? 2. Good. On this example, they keep going down until we have all prime factors, which is fine. So we know that this is prime, and we know that this is prime. For 6, we have something times 3. What times 3 equals 6, Mary? 2. Very good. Do we have all prime factors here now, boys and girls? Yes. Okay? So when we show prime factorization, you need to put the numbers in order from least to greatest. Okay? So 180 equals 2 times 2 times 3 times 3 times 5. Okay? So the prime factorization of 180 is 2 times 2 times 3 times 3 times 5. Okay? Now, just because we use 10 and 18 here doesn't mean that that's the only way we can get our prime factorization. For example, right here, we want to use some divisibility rules. We know that 180 is even, so it's divisible by 2. So 2 times 90, I think is what Riley had said early, will equal 180. So we have 2 times 90. Is 2 a prime number? Yes, so let's just put 2 all the way down here. Now let's look at 90. We know it's an even number. 2 times what is 90? Who knows that? 2 times what? Emmanuel?
45.
45, very good. Is 2 a prime number? Yes, so let's bring that all the way down. Now we have 45. 3 times what is 45? Mary?
15.
Very good, 15. Is 3 a prime number? Yes. And then what can we multiply to get 15? Corbin.
3 times 15. 3 times 5.
3 times 5. Very good. And look, we have the same prime factorization. 2 times 2 times 3 times 3 times 5. Okay? Does everyone understand how to use this factor tree? Okay. Let's do another example. Okay. This is another way to do it. It's called a ladder diagram. Personally, I'm not a fan, but if you like it, then you can use it, okay? So the key for a code is based on the prime factorization of 140. Find the prime factorization of 140. So we're going to choose a prime factor of 140, and we're going to continue dividing by prime factors only until the quotient is 1. So we're going to start here, 140. Divided by 2 is 70. 70 divided by 7, because that's a prime factor, is 10. 10 divided by what will give me 2? 5. And then 2 divided by 2 is 1. These are your prime factors. So 140 would equal, in order from least to greatest, 2 times 2 times 5 times 7. Okay? Now, I don't always have to start out with 2. I can start out with 5 because I know that 140 is divisible by 10 and 5. So 140 divided by 5 is what?
28.
Yep, 28. 28 divided by 2 is 14. 14 divided by what is 2? 7. And then 2 divided by 2 is 1. Here are our prime factors again. Do they match up? Yes. So the prime factorization of 140 is 2 times 2 times 5 times 7. Okay? 2 different ways, just like we did with the factor tree. Okay? Now, please get out your spiral, and I'm going to give you 2 examples that you can put in your spiral.